Hey, so today we are going to talk about DNS. And I know what you might be thinking. You might be thinking, seriously, dude, what the hell? DNS is pretty straightforward. Well, for the most part, you're pretty much correct. But because you are working on your path of building out some mad DevOps skills, there's a few things that I want to teach you about, like the different types of DNS records there are, when to use them, what they're going to do for you, and ultimately that just might save you from spending a lot of time, energy, and frustration doing something really stupid that doesn't solve your problem anyway. So let's jump into it. Hey, I'm Will Button from DevOps for Developers, where I teach you the DevOps skills you need to increase your developer skill set. And today we're going to be talking about DNS. So there's different types of records used in DNS, and we're going to go through those today. But let's take a step back just in case you're not familiar with it and talk about what DNS is. So when you go to something on the internet, whether you're using your browser or email or an API call or whatever, you go to something by its DNS name most of the time, like api.willbutton.co. Well, that name really doesn't mean anything. It's kind of like a vanity name that just makes it easier for us humans to interact with the computers. What happens in the background is your computer or the server that you're using does a DNS lookup to get the IP address that's hosting that resource. So api.willbutton.co is going to come back as an IP address, and then you're going to route over the internet to that IP address, not to the actual domain name itself. So there's different types of records that make all of this stuff work together, and I'm going to be showing you in my DNS console what some of those look like. And I'm using AWS Route 53 for my DNS. So if you're using something else, your console may look a little bit different, but it'll have all of the same features because DNS is an international standard. So it works the same regardless who your provider is or what your console for interacting with it looks like. So let's start with the most basic record. The basic record is an A record. And I want you to kind of think of that as like just a name for a specific person or a specific entity. So if I walk into somebody's office and say, hey, I'm here to see John, I need to see John. I can't talk to Bill or Susan or Ted or anyone else. It's got to be John, and it's got to be him specifically. So that's an A record in DNS. So if we take a look at my Route 53 console here, I've got a couple of A records I can show you. So the first one is just the root record itself, willbutton.co, and it points to this specific IP address. There's nowhere else it can go. There's no one else that can answer for that. Another one that may be a little bit better example for you is if we look down here at this one, vpn.willbutton.co is an A record, and it points to this IP address, which conveniently enough is the IP address for my VPN server. So when I'm trying to establish a VPN connection, it's got to go to that server. Any other server may not be running VPN services, and if they are running VPN services, probably doesn't have my credentials that I need to connect to my network. So we've got to go talk to that server. The next one I want to talk to you about is the SOA, or Start of Authority. And this is what tells the internet who hosts your DNS, who knows about your DNS. As I mentioned earlier, I'm using AWS Route 53, and so it stands to reason that the start of authority for my domain is going to be the AWS DNS servers. And now that doesn't mean that AWS is the only one who has a copy of my DNS records, because DNS servers will propagate to each other so that any DNS server you talk to is likely going to have the DNS lookup records that you need to carry on about your business. The only difference is like who owns the authority for that. So if you go to your DNS servers and look up vpn.willbutton.co, it'll give you a value, but you can't change that value because only my console using AWS DNS servers is the one who's allowed to actually say what value there should be for that particular record. So now if you are able to hijack someone's DNS and become the start of authority for that, or answer for requests that you're not authoritative on, that's called DNS poisoning, and it's a common attack method for taking over someone's site and redirecting their traffic to your own servers versus their servers. So the next record we're going to talk about, or the next type of record we're going to talk about, is a CNAME, and it's very similar to an A record, except I want you to think of it as more of like a nickname, all right? Now, an A record has to point to an IP address, but a CNAME can actually point to another DNS name, right? And you see this a lot with load balancers in AWS as one particular example. Whenever you spin up a load balancer in AWS, you get this monster DNS name that's something like, GHG213489.us-east-1.amazonaws.com. Well, nobody's going to remember that. And most of the time you don't have to remember it, but it sure does make it handy whenever you're troubleshooting if you can use something that's a name you can easily recognize, like a name in your own domain, like api.willbutton.co or something like that. So jump back over into the console here, and I've got a couple of different CNAMEs set up here that you can look at. We've got demo.willbutton.co. It's a CNAME, and it points to my root record of willbutton.co. Another one that I have set up here is drip.willbutton.co, and it's pointing over to SendGrid, used to manage my drip email campaigns. So again, pretty straightforward. A records point to IP addresses. CNAMEs can point to other A records and or other DNS names, and those DNS names can be either inside your own hosted zone, or they can point to other domains, whichever serves the purpose that you need them to serve. All right, so next let's talk about MX records, and MX stands for Mail Exchange. Basically that just means who are the guys responsible for hosting the email for this particular domain. For example, if you send me an email at will@willbutton.co, your email server is going to say, hey, I got an email for will@willbutton.co, who the hell wants it? So it's going to do that by looking up my domain, grabbing the MX records, and it's going to get a list of the email servers that I have. And now MX records are kind of unique in the fact that you can have multiple values in the record type itself, and each one of those is weighted, right? So I've got a 10 followed by a space and then the name of a mail server, and if you haven't figured it out by now, I'm using Google for my email service. And so each of these are weighted. And the way I like to think of it is the heavier numbers sink towards the bottom of the record, right? And that's just Google's order of preference in how they want to process my mail. They want this dude to do it first. Alt 1 gets a second chance at it, Alt 2, and then on down the list. And I didn't actually have anything to do with this. Whenever I set up Gmail to host my email, they actually gave me these values, so the weights and the priorities set here are determined by Google, not by me, which makes it kind of nice because I don't know how they want the email routed. And then that's going to tee us up right into talking about text records. And text records are kind of just informational records that help different services understand what your domain does and does not offer. For example, if we talk about walking into a store and then you ask the clerk at the store, hey, do y'all sell personal tobacco and tobacco related accessories? And the sales clerk's like, dude, we totally sell tobacco and tobacco smoking accessories. Here's a brochure on exactly what we've got. And you take the brochure and you read all about it and you decide whether or not that's the right thing for you. So if we put that into a practical example that you can actually relate to and use, a really common use for text records is for SPF, the Sender Policy Framework, and DKIM, which is used for routing email. So One way that you're going to encounter this is marketing is going to come to you one day and say, hey, we signed up for this third-party email delivery service, and all of our spam that we're sending to our potential customers is going to their spam box instead of to their inbox, and now that's your problem. So the thing that you want to do there is whenever, let's say that I send you an email, right? And your mail server is going to get that email from me and say, hey, I got an email from this dude, Will at willbutton.co. It came from this server. Is that his email server, or is that some other server? And it's going to use a text record to figure that out. So it's going to go to my domain, pull up my text record right here, and then it's going to look at the SPF record inside of there, and that's going to tell it that anything coming from the servers identified in _spf.google.com is valid mail from me. That way your server knows that it's a legitimate email coming from an authorized server. So in the case of the marketing example that I gave you, what you're going to have to do there is figure out who it is that's sending emails on your behalf. Let's just pick an example and say it's SendGrid. So you're going to add SendGrid's email servers to your own SPF record so that as you send those marketing messages out to those different customers, when it hits their mail server, they're going to say, hey, I got this email. It came from this server over at SendGrid. Is that authorized to send email from your domain? It's going to pull up your SPF record and validate that it is. And if it is, then it's going to go through and rank it a little bit higher. It doesn't mean it's not going to end up in spam, but it's going to be ranked a little bit higher that it's likely not spam. Otherwise, it's just going to say, no, we don't know who the hell this server is, and send it right to the spam box. And so the final record I want to talk to you about, or the final type of record I want to talk to you about, are GeoDNS records. And so what GeoDNS does is it looks at the IP address of the person making the request, and on your side for your GeoDNS entry, you're going to have a list of different servers that are capable of responding. And so the GeoDNS query is actually going to pick the server that's closest to the person making that request. Now you'll see this a lot in like video and audio streaming applications where they will host those assets on different continents, in the US, in Europe, in Australia, so that when users from those locations try to access that resource, they get a copy that's close to them. CDN solutions are another type of service that makes heavy use of GeoDNS. So if you think GeoDNS might be right for you, I've got a video I did on the subject, so I'll link that right up here and you can check that out. Odds are it's probably not going to apply to you in your day-to-day activities, but check that video out. There's a whole bunch of stuff in there to help you make that decision for yourself. All right, so the last thing I want to cover here is talking about DNS timing and workarounds to get around DNS. So like when talking with external services out of your control, like using third-party APIs, third-party mail services, different things like that, there's really no way to get around DNS. You just got to use it. And for the most part, it's really, really reliable. DNS has been around since the mid-'80s, I think, so they've kind of ironed out the bugs for it, and it's pretty performant. Now, one of the places where it might come up as an issue for you is if you're using DNS heavily internally to your application and you've got a large number of DNS lookups. So let's just take a look here. So what I did here was a dig on my own domain, right? And the query time was 121 milliseconds. So now keep in mind that's me from my workstation here in my office going to my DNS provider and doing a query that way. And it was 121 milliseconds, which is not bad, but where this comes into to be an issue is if I've got an API server that I've built that relies on DNS for accessing other things like microservices type architecture, and my target response time is 200 milliseconds, and if I blow 100 milliseconds of that doing a DNS lookup, that's going to cause me performance issues, right? And so that's kind of the area where DNS can cause you some grief. But I want you to really think carefully before you decide that you need to rip out DNS and go with another solution. Because once you do that, some of the things I've seen done are people who will store IP addresses manually, and use those IP addresses to avoid a DNS lookup entirely, which is okay, assuming that your IP address never changes, which is really, really unlikely in today's modern software architecture. The other thing is to use something like etcd or Zookeeper or Kafka to store DNS entries. That's could work, but now you've got the added overhead of maintaining those services. Service discovery, though, is really popular for solving that problem and seems to be the most reliable way of doing that. But before you go down any of those, by the way, service discovery is kind of like a little micro DNS thing. What it does is it allows you to give a server the names of all your services, like api.willbutton.co, and say, hey, if anyone asks if you know about api.willbutton.co, give them one of these IP addresses. It doesn't matter which one, just give them one. And so that's kind of the service discovery model, which is very similar to DNS, but it's done at a very localized level inside your environment. So you avoid the latency of going to an authoritative DNS server to get that information. But before you go down that path, though, I want you to really look at your overall architecture and how many DNS queries you're actually making, and make sure that that's the right amount. If a single API call is making 3 or 4 different DNS queries, it could indicate, that you've got some architectural inefficiencies in there that you might want to address. Because in addition to the DNS latency issue, you've also got network latency, and if you're calling those services, you've got the overhead, the packet overhead, or the time to first byte overhead from contacting those services and starting a connection and beginning that request process. So there's a lot of overhead involved in that, and I want you to really think about how your architecture looks and if you're doing the right thing. And if you believe that you are, then yeah, one of those other services that I mentioned earlier might be the right answer for you. Bottom line, though, is DNS service is really, really robust. It's really scalable, performant, and it's just tried and true, battle tested. So think long and hard before you go ripping something like that out of your environment. So that's really about all I know about DNS. And I think that'll cover you in a high percentage of your DNS work as a DevOps engineer. If there's something I missed, though, be sure and let me know down in the comments. I'd love to hear your thoughts. And while you're doing that, hit the subscribe button, hit the notify button, because I'm releasing 3 videos a week now on DevOps topics. And yeah, so I'll see you in a couple days.